then I just have to add them up. That's what you do, because the formula is k squared, so you have 1 plus 4 plus 9 plus 16 plus 25, okay? And that would be your solution, so then you'd add that up. So if I'm doing, now some of these, and I'm not gonna do this, some of these don't start at 1. They want to find the sum from j equals 3 to 5. So this would be 1 over 3 plus 1 over 4 plus 1 over 5, okay? Now, on letter D, they try to trick you. Look at that letter D. They want the summation from I equals 1 to 6 of 2. All right? When I equals 1, it's 2. When I equals 2, it's still 2. When I equals 3, it's 2. When I equals 4, it's 2. When it's 5, it's 2. And when 6 is 2. So you go 6 of these 2. Okay? So there's no I to put in the formula. So that's a partial sum. Okay? Doesn't follow, you know, you're just gonna put n in. So if we need to find the first 4 terms of this sequence, okay? So the first term, a1, is gonna be 1 squared minus 2. So the first term is negative 1, okay? The second term, that means n is gonna be 2. So that's 2 squared minus 2. So that's 4 minus 2, so it's 2. The third term, a3, is going to be 3 squared minus 2, and that's 7. And the fourth term, a4, is going to be 4 squared minus 2, 16 minus 2 would be 14. So there's the first 4 terms right there in that sequence. No, it doesn't follow a specific pattern. Now, I would have had, if they would have given me this formula and say, what's my formula, I would have had a lot of trouble for that. I would have. You guys probably would not. Okay? All right, look at number 2 then, okay? Okay, now this one's a little easier, okay? The first term is going to be negative 73 plus 100 times 1, or 100. So that's negative 73 plus 100, and that's going to be 27. 100 minus 73. The second term is going to be negative 73 plus 100 times 2, or 200, and that's going to be 127. The third term is negative 73 plus 100 times 3, or 300, and that's going to be 227. Is there any guess what the fourth term would be? So it's going to be 327. So there's your sequence right there. Okay, now this pattern is different, it goes up by 100 every time. Okay. All right, number 3. So the first term is going to be 2 times 1, which is 2 to the, excuse me, which is 4, okay? 2 squared is 4. The second term, 2 times 2, which is 4, and it's squared, so that's going to be 16. The third term is going to be 2 times 3, which is 6 and squared, so that's 36, okay?
Well, there's 3 right there.
Oh,
Sorry.
That's right. Okay. And the fourth term would be 2 times 4, which is 8 squared, so that'll be 64. So it's 4, 16, 36, and 64. Number 4, right there. The first term is 1/2 times 1. So that's 1/2. The second term is 1/2 times 2, and that's 1. The third term is 1/2 times 3, so that's 3 over 2. And the fourth term is 1/2 times 4, which is 2. All right, now, the next 2 problems, okay, 5 and 6, okay, this is the recursive one. Okay, they give you the first term, and they want to know now a to the n would be the next term after this one. So this is the first, that's gonna go here, and then that's gonna be the second. So the second term, a2 equals 2 plus a1 over 2. Now, a1, you know, is negative 22. So 2 plus negative 22 is negative 20 over 2. So the answer is negative 10. So the second term is negative 10. So we started with negative 22, and we went to negative 10.
So that negative 1 on the top doesn't matter.
Where?
The a to the n minus 1.
Yeah,
We just
that's,
do a to the-
okay, see, that's a 2 and that's a 1. So this one has to be 1 less than the one you're finding. The n minus 1 and the n, that's a formula. So this is the one in front of this one. N minus 1 is 1 less than this one. If that's 2, that's gotta be a 1. So if this is the third term,
oh,
it's going to be 2 plus a2 over 2. See, this one is 1 less than this one.
okay.
Okay, now that's for some of us, this one is 1 less than this one. N minus 1 means it's gotta be 1 less. So a2, that's gotta be a1. So if I wanna find the third term, then this has gotta be 1 less than the third, which is the second term. That's what the n minus 1 means. Okay? Alright, and that takes a while to comprehend. Do we know the second term is negative 10? So this is 2 plus negative 10 over 2. So we add the top together. So this goes in there as negative 10, so you get negative 8 over 2, which is negative 4. Come and get this up here. All right, now I need to find the fourth term, okay? So the fourth term, using that formula, is 2 plus A3 divided by 2. Now, A3 is negative 4. So that's 2 plus negative 4, which would be negative 2 over 2. So that one's going to be negative 1. Now you could keep going on and on, okay? You could find the fifth and sixth, but they want you to find in this one the first four terms. Okay, look at number 6, okay? Okay, the first term is 1, so that's going to go right there. So our second term, A2, is going to be A1 plus N. Now N is what N is the first term, okay, would be 1 here, okay? No, this one's gotta be, N's gotta be 2 on this one, okay? Okay, notice in the second one, N, if A to the N, this has gotta be, that N has to be 2. So this is gonna be 1 plus 2. So we start with 1, the next term is 3. The third term equals the second term plus N. Now right there, that's what N equals, 3, okay? So this is going to be A2, which is 3, plus N, which is 3. So that's going to be 6. All right, would all of you find the fourth term? What is the fourth term? So it's going to be 10. Find the next 3 terms after negative 48. Can anyone tell us what's happening here? So you're timesing by 2 each time. So if we times negative 48 by 2, we get negative 96. So now you need to times that one by 2. Negative 192. And if you times this one by 2, you get negative 384. All right, how about there on 18? What's happening on 18? So we add 9 each time. So if you add 9 to 18, you get 27. And if you add 9 again, you get 36. So if you add 9, you get 45. All right, now this is the top, now explicit formula, that's the formula up here like on number 1, n squared minus 2. That's the formula that we want to find, okay? Now, what I can see, this is 1 squared and 3 squared, and 5 squared, and 7 squared, and 9 squared, okay? Now, this is when n, now remember that n equals 1 here, and n equals 2 to get 3. And n equals 3 to get this one. Now, we did a problem at the very first in the book where we got 1, 3, 5. Remember what that formula was? Yeah, so see, that was 2n minus 1. So when we put 1 in, you get 2 minus 1, which is 1. When we put 2 in, you get 4 minus 1, which is 3. When we put 3 in, that's 6 minus 1. Okay, so what do I have to do to 2n minus 1?
Square it.
Square. So there is the, now we would write a to the n, your general term is 2n minus 1 in parentheses squared. So that's the explicit formula that they're asking. All right, now on number 10, notice that each one of these are 100 more. Notice that problem number 2 was very similar to that. Now look at the formula. It's negative 73 plus 100n. Okay? Now this one's going to be very close to the same, but we're not going to minus 73, are we? Yeah, so it's negative 66 plus 100n. So we get negative 66 plus 100 is the 34, and then negative 66 plus 200 is 134, etc. Okay? All right, now, in this chapter, in this section, these are the hardest ones for some reason. Evaluate, this is a sum. We are going to add these up. When k equals 1 to 5, we're going to add up 5 different items right here. And the formula is k times k plus 1. And we start when k equals 1. So when k equals 1, we get 1 times 1 plus 1. Okay? Remember, there's your formula. K is 1. And then so that's going to be 1 times 2, which is 2. Okay. Now, when k equals 2, I replace all the k's with 2. That's going to be 2 times 3. 2 plus 1, so I get 6. When k equals 3, I get 3 times 4, which is 12. When k equals 4, I get 4 times 5, which is 20. And what happens when k equals 5? What do you end up with? 5 times 6, which is 30. So you add all of this up, okay? So it looks like we end up with 7. On the 12th one, okay, it's the same thing, 2m. So when it's 1, it's going to be 2. When m is 2, 2 times 2 is going to be 4. When m is 3, it's going to be 6. When it's 4, it's going to be 8. When it's 5, it's going to be 10. When it's 6, it's going to be 12. And when it's 7, it's going to be 14. I might get 56 for that. All right, we have, I guess, 2 more to add up here on 13. They're almost the same. So when A is 1, you get 2 times 1 squared minus 2, which is 0. So you get 0 when it's 1. Okay, when A is 2, now you put 2 in for A, so that's 2 times 4, which is 8 minus 2. So I get a 6. Okay, when A is 3, this is what A equals. Now that's 3 squared. So that's going to be 2 times 9, which is 18 minus 2. Okay, now don't let me make a mistake here. You guys see that I'm doing something weird. Okay, now we got to go from A equals 1 to 6. So I got to put A is 4 in there. Now that's 4 squared, so that's 2 times 16, which is 32 minus 2. So that's going to be 30. When A is 5, that's 2 times 25, or 50 minus 2. So that's 48. And then our last partial sum, we're adding it when A is 6. Now that's 6 squared, so that's 2 times 36, or 72 minus 2. This would be 7. If I add those two, that's 100. And these two are 22 and 48. That makes it 70. So I get 170. All right, what's the first term when k equals 1 on this one? And when you get an arithmetic, you add the same number every time, okay? So the sequence of numbers would be something like 1, and then 3, and then 5, and then 7, and then 9. We are adding 2 each time, okay? Now, it might be 1 and -1 and -3 and -5 and -7. We're adding -2. So you can also add a negative number. But you're going to be adding something, and this is called the common difference. So we call that D. The common difference is 2, okay? And we don't always have to start with 1, okay? But there's a formula for this, AN equals A1, which is the first term, plus n minus 1 in parentheses times D, which is the common difference. And notice that's the formula here. Right there, okay? The explicit formula. Okay, now this is the one you always fall back on. This is your safety valve. If you run into trouble, we always go back here. Okay? Now, remember that recursive that we did a little bit here? Remember, if this is the first term, this is the second. Remember that n minus 1 and n? And all we're doing is adding the difference each time. So see, this one is 1 plus 2, which is 3. This is 3 plus 2, 5 plus 2, 7 plus 2. So your next term is the term in front of it plus whatever the difference is. That's called the recursive formula, okay? You are going to have to write this and this, but you're going to replace them with numbers, okay? This one you just replace with the difference. So whatever D is, so on this one, you would put a to the n is a to the n minus 1 plus 2, and this one would be plus negative 2. Okay, but this one, you need to put this and this in, okay? Now, do you know what the first term is here? 1. Do you know what the common difference is?
Yeah.
So this formula, a to the n is going to be 1 plus n minus 1 times 2. That's what you need to do. That's all. That's your formula, or the explicit formula for this sequence. And what's the only difference for this one? Then here, what would you do different for this one? This is the only thing different, because 1 is still the first term. So this one would be an would be 1 plus in parentheses n minus 1, but then you times it by negative.